Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Starting a new playlist now, it's about second law of motion. The prerequisite for this is a previous playlist about forces. It's very short, but it's very important. We have to understand that force is a result of interaction of two bodies. That was the goal of this short forces playlist. Now, second law of motion, it ties force and acceleration. So people write it in the form F vector equal ma vector. But in fact, it should be written differently. It should be A equal F divided over m. And what's the difference, you may ask? The difference is this kind of implies that acceleration defines the force, which is not really the case. It always the force that's primary, and forces create an acceleration. So force create an acceleration. So it should be like some other acceleration is proportional to the force, or acceleration equal kf. K is a coefficient of proportionality factor. But anyway, it's written like this, and this is a history to this, and in the end of the day when solving problems it is exactly the same. And of course this should be like sigma, meaning that the sum of all forces that acts on the body, and it's a vector sum F3 equals ma, and this is like that, but I will be writing it very often, but a little bit further down. The first problem is really very simple. They want us to find the acceleration of free-falling body, and it may sound like a joke, because we already know from kinematics that g is this vector, and this is a free-falling body, and the body falls, and as long as it's moving on this direction, it always g, and it always directed down. And so what's the question? But notice they want us to derive this from the second law of motion, because so far we were just like, okay, the teacher told us free-falling body, the textbooks tells us, or they did like in reality some experiments 400 years ago, and they defined from this experiment, from observation, that body like would be falling with g 9.8 meter per second, and it's provided there would be no drag, no resistance from the air, which was very difficult at the time to produce this experiment, because how you eliminate the drag, how you eliminate the resistance from the air. But anyway, it's an experimental fact. Here they ask us to derive this experimental fact from the law of motion, and I will just write it straight, this x, and I will forget about vectors because it's only one single projection of this vector on this x, and I will say the body, and this is a point mass, a dot, and it has only one force that acts on it, and this force is called mg, and mg is gravity. And that's all that we need to know, and that's always the case. You look on the body above the surface and you say mg, you know mass, you know g, and you know the gravity, and the gravity is mg. And that's it. Later on we will find out that if we will move further higher up above the ground, this g would not be the same, and this gravitational force will change. But consider we're living 400 years ago, time of Newton, and nobody was far away from the ground, and so it was a quite normal assumption that gravity is constant at mg. In fact, it was his genius that he was able to deduce that gravitational force is falling as r squared, but it's completely different thing. This is astonishing. But to believe that mg acts on every body close to Earth is just normal thing. So now we have F equal ma. And I can write it in a vector form, and I can say x projection F equal ma, and a projection, y projection is nothing, so I don't even write it down because it's one-dimensional movement. So F equal ma, this is the law of motion. Instead of a, I put mg. I have mg equal ma, and I have a equal g. And that's it. We just derived that acceleration of every body is g, free falling above the ground, and this acceleration is g, and we did it using second law of motion. So instead of asking ourselves or taking it like as a trust, matter of trust, that acceleration of the body is g, we can ask why it is g. And then we dig a little bit deeper, and we say, oh, that's because of law of motion, second law of motion. And look how nicely second law of motion allows us to derive the force, the acceleration. So we have the force, and from force we derive acceleration. And that's the point of this exercise. And if you liked it, like. If you want more, subscribe bell. If you have a question, put it in. Thank you.